Hello everyone. Today is the 16th day of Leetcode 75 challenge. Let's begin with the 16th question. Question number 1004. Maximum or max consecutive ones 3. The level of the problem is medium. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in easiest way possible. You are given a binary array nums and an integer k. Okay. Binary means 1 and 0 only. So you need to find contiguous subarray that contains a maximum number of consecutive ones by flipping at most k zeros. Okay. So what is contiguous subarray means in this case is that an element in the subarray appears consecutively without any gap. For example, if you have an array of binary numbers and if you take out this subarray, there could be multiple subarrays. This can be a subarray taking only 0 and this 1 could be a subarray. Taking only 1 and 0 could be a subarray, or taking 0, this one 1 and this 1 could be a subarray, right? But in our case, they're asking it to be a contiguous. Contiguous means there the relative order has to be maintained plus the value has to be contiguous means adjacent to each other. For example, if this is a binary subarray, if I were to take a k size contiguous subarray, whatever size it could be, it has to be 0, comma 1, comma 1, right? It has to be adjacent. And you are allowed to flip at most k zeros to make it 1. And this will help in maximize the length of the one's consecutive length. Okay. So our task is to return the maximum number of consecutive ones in the array after flipping at most k zeros. Okay. So basically the question is asking we have to flip at least k zeros, the k will be provided to us, so that the subarray, the contiguous subarray which we get, has the maximum number of ones present in it. Now the length is going from 1 to 10 to the power 5, and nums of I is either 0 or 1, and k value could be from 0 to nums length. Okay. Now let's move to the next slide. Now let's understand the input output. So here you can see uh, k is 2, which means you can flip at most two zeros, right? So if you take these three ones and we try to flip these zeros, we get total one to be 5, right? That's great. Let's take these two zeros and these four ones. We get how much? We get 6, right? Because we converted these zeros to ones and we're allowed to do at most two zeros. So assume it to be 1 comma 1 after that, right? And what else we can do? The other combination is taking this 0 and the last 0, we get 6. So the output is 6 in this case. Now let's take this example. Here k could be of maximum 3. So we modified these two zeros to 1. We have this 1 and here there is 1. If we flip this 0, right? So we get total 2 plus 1, we get 5. So according to our output, 10 should be the answer, but we are getting 5 here. So let's try another. We can see that if you flip these two zeros to 1 and this 0 to 1, how many ones you are getting total? These two, these two, 4, 5, 6, 7, 8, 9, 10. Yeah, so we got the 10 size of array having consecutive 1. Okay, and if we try doing this one, right? If we have converted this, we could have got 1 comma 1 comma 1, and this 4, 5, 6, 7, 8, 9. We might have been missed with 1 0, right? So this is the most efficient solution. Okay, I hope you understood this input output explanation, how we are getting consecutive subarrays consisting of only ones. Now let's move to the next slide. To understand what the problem is asking, we should build up an intuition to the problem, right? Okay, now let's take the example of this rope, right? Imagine you have a long rope made up of strong knots, weak knots, zeros, and your goal is to find the longest continuous stretch of strong knots to hold the maximum weight. Fine. And you can reinforce up to k weak knots and turn them into a strong knot. So they what the thing is saying that you are given a rope and there are multiple knots in it. Let this be the knots. Okay, and few of the knots could be weak, which is represented as 0, and others would be 1, which is represented as 1, which are strong. and your task is to find the maximum length of the knot within the knot that which is strong, and you have been given an advantage that th- you could modify k weak knots and include them in the strong knots. Okay, so what could be the easiest understanding of the problem? What we can come up with is that we can grab the rope from one end and move forward, right? If we grab it from here and we start moving forward, right? Now we will keep on counting how many strong knots we have received till now, right? Assume this is a strong node, you took this, then you took that, then you took the third one, right? You're counting it. That's the what thing which comes to our mind. Now, whenever we encounter a weak knot, what we can do? Since we have been given an advantage of reinforcing k weak knots, what we will do? We will try to modify this weak knot. Let's assume that the fourth knot was a weak knot. So you convert it into a strong knot. Okay, so you converted this as a strong knot. Okay, that's great. Now you move ahead after converting it, right? But before doing the conversion, we have to think whether the weak knots, which we can reinforce k times, haven't we used all of them, or we have left with few of it, right? If we have used every of it, we cannot, convert it to a strong knot. Now, assume we had two weak knots, and this the second knot was also weak, so you converted this also. Now you have zero weak knots left with you. Fine. Let me stretch this. Okay. Now let this be the other notes, strong notes. We will think of it afterwards. Okay. Till now you have it, and let it be the strong knot, and let this be also the weak knot. Okay. Okay. Weak knot. W. Now, if we have used all of our weak knots reinforcement, converting them to strong knots, now what we can do? We know that till this point, from the starting part till the current index, we have a length of a sub rope which is the strongest till now, consisting of how many knots? 5 knots. Great. So our intuition could be that yeah, we can store that 5 with us as the answer, right? Because till now we got one answer, right? And we are pretty sure it is correct one. Now you know that the rope is not only of 5 knots, it is of 100 knots. And you have used all of your K knots. So what you can do? You can do one thing. You know that hundreds of knots are there, right? And we have used all of our weak knots transitions to one. So what we can do? What if we come to the weak knots and reduce our use of K? What I'm trying to say here is that I will push my hand. Right, we are already reinforced of them. The rope starts to weaken, right? To fix that, we have to do what? Just keep in mind, assume a rope in your hand, and you have converted the weak notes to strong notes, which is of length 5, okay, which is a continuous, understand is a continuous subarray of a given array, okay. Now you cannot go down. You have to go up because in rope you have to climb up, right? So what you thought, okay, if I lift the previous strong notes, if you drop these strong notes and move ahead till the time you don't get weak notes. This is the weak note here, okay? Then you came till here and you got a one weak note. So what you can do? You remove it. You remove it from your consideration that till now you are not using this weak note to convert into a strong note. So what happens? K again becomes to 1, right? Now when it becomes to 1, you can utilize that 1 in the weak note which you got ahead, right? In here. So what this tells you is that now your next contiguous subarray is basically starting from last weak node here, right? So in the easier manner to fix this, you must let go the earliest weak node that you enforced, right? This was our earliest weak node. This ensures that at any given moment you never reinforce more than key weak nodes, right? So when you get rid of this weak node and your Ka value becomes 1 and you come in this part, you know now that this part is no longer needed because we got the length is 5 and it's no longer needed, right? And when you start from this weak node, and since this was also the weak node, you use the one here, right? Then you move ahead, you check it is a strong node, it is a strong node. So you got another length of 4 strong node. Okay. Now this helps us to keep track of the strongest section. And as you move forward, always track the longest stretch of the strong nodes. You are able to hold using at most K enforcement, right? And this ensures that by the time we reach at the end, we know the maximum strength of the rope we hold. Now let me make it more clear. Let's visualize the situation by taking an array. So this is an array, say, uh, and suppose it contains 0 here, 1, 1, 0, then 1, 1, 0, 0, 1. I just given some random values, right? And k is 2. Now let's see what is the strongest node here, right? So a person comes, he takes, okay, this is the strongest weak node, right? So he converts it to a 1. So he holds this end of the knot. This is a rope in a form of array. Then he moves his hand, its hand, and it says it is a strong node. Then here, strong knot. Here, it is a weak knot. So since he has left one k value with him, so he will remove this and make it 1. Then he will move ahead. It is a 1. He will move ahead. It is a strong knot. Okay. Now again, when he comes here, he sees that okay, I have used all of my k knots and I cannot use it anymore. But till here, from starting to this index, the length of the strongest length was 3 plus 3, 6. It was 6. Fine. Now he thinks that if I remove this knot from my hand, or if I weaken the first knot which I received, the k value will increase by 1, and I can use that one for the further weak knots which I get in the way, right? So what he does, he just removes this weak knot and comes here, right? And then he is able to use the weak knot present here and convert it to 1. Great. So what is the length now? It's 3, 3, 6, right? Now, again he comes here, he sees that, okay, again I got a weak knot, but I have utilized all of my weak knots. So what he will do? His first thought is that, what if I remove the weak knot which is present in this subsection of my holding, right? Which is this. So if we remove this and converts it to 0 back, now again he is starting from here till here. So now he has how many? He has a length of 2 to 4, right? Then he moves ahead, then he has a length of 5. So if you can visualize here, we are sliding the windows depending upon the size of k, right? And whenever the size of k becomes 0, we try to shrink the window from the left hand side, right? So if you can recall, this is a sliding window question, but this is a dynamic window, and here we are using the concept of shrinking, right? So I hope you understood the explanation and why we are using sliding window here and how we forged down concluded that why how the problem is of sliding window. Now let's move to the next slide. Before going to the approach, let's understand what is sliding window concept in more deeper meaning or in more deep depth, right? So sliding window is a powerful technique used to efficiently solve problems involving contiguous subarrays or subsequences. I hope you understand what is subarrays, right? If this is a subarray with some values, the subarray for it will be x, n, z. We follow the relative order given in the original array. but it may be continuous or it may not be continuous. Fine. And same case in the case of string also. Now, how it works? First, we define a window, usually a fixed size of k or dynamic size. Window could be a dynamic size also, or it could be of fixed size also. Uh, that could be derived from the question itself, what the question is asking, over a part of the array or string. Now, we just start by calculating the result for the initial window. Now, whatever the calculation has to be done for a particular window, like adding the complete value, taking the average of those of that window, taking the multiplication, or anything whichever is asked in the question. Then slide the window one step at a time. Add the new element coming to the new window, which is in the right side, and removing the old element that is leaving the window, which is from the left side. Now keep updating the result while sliding. So it goes like this is the array, and this is one window from start to k size. Now your task is we will add new element, that this will be the new element added, and you remove the last element, that this will be the last element removed. So our array just moved by one, right? This is how it goes. Now, why is it efficient to use? Now, instead of recalculating the result from scratch every time, we just have to adjust the result using a new and outgoing element. Just requires O of n time in that. And the total complexity becomes to O of n instead of O of n into k, which you get from brute force approach. Brute force approach is basically you start from I, go till n, k, this is size. Then again you start with I plus 1, and again you go from k times, and this is how you go, right? So this boils down our complexity to O of n. Now let's move to the next slide. Now, variations of the sliding windows. Now, where could you use the sliding windows and what could be the variations of it, right? So let's understand that also. If it is a fixed size sliding window, if the size is given to you, it is fixed that it will be a k of suppose size is always 5 and it won't be changing. So just have 5 and sliding one step at a time and adjusting the result. Use cases could be maximum, minimum, or sum of fixed length of array. Example is maximum subarray, maximum sum or average of subarray of size k. Now there could be a two pointer variation also. The left and right pointers define the window here, or expand a string based on the conditions, like finding pairs, minimum, maximum range. Example could be container with most water. We solved this question in our previous videos. Please look into those also regarding the two pointer variation, container with most water. The third type or third variation will be monotonic sliding window. We use a DQ to keep elements in order while sliding. DQ is a data structure in a nutshell is that we can push and pop from back, push or pop from front. Right? This is DQ. The use case could be maintain a sorted or maximum minimum values in a window. Maximum in each subarray of size k. Whenever you have to maintain a sorted maximum or minimum values in the window, we have to use DQ, and this is called a monotonic sliding window technique. Now the fourth variation will be dynamic size sliding window. We expand the window until a condition is met. Shrink if it is violated. Now expansion of the window is done from the right hand side and shrink is done from the left hand side. Right? If we expand it like this, then you shrink it from the back this way. The use case is longest or shortest substrings satisfying a condition. Example could be of the problem longest substrings with k distinct characters. Now the fifth variation will be circular sliding window. Window wraps around an array boundaries like a ring. The array becomes a ring. Fine. Use case would be sum or minimum maximum in the circular arrays and maximum sum of circular subarray. So these are some of the most commonly used variations I have defined here of the sliding window technique. I hope you get a gist of sliding windows and their use cases and examples of the problems I have mentioned here. If it is good to you, please go and look at these examples and you can understand how these sliding window techniques are being used. Now let's move to the next slide. Now, where sliding window is used, okay, in a nutshell, if you see in subarray subsequence problems like having maximum, minimum, average of size k, longest, shortest array satisfying a condition. In string problems, longest substrings without repeating characters, longest substrings with k distinct characters, and minimum window substring. Now, pairing and range problem also. Container with most alter sum of two elements closest to zero, number of subarrays with some within a range. Now, frequency counting using set or hash map. Longest substrings with k most distinct characters, find anagrams in a string. Now, I have given you the sliding windows where it is being used here, and these are some of the examples or name of the problems. I have given you the names of the problems and examples where this sliding windows is being used. It is just a gist. So you could go and look at this the problem and understand that how the sliding windows are being used in this kind of problems. I hope you understood the concept of sliding window, how it works, what are the variations of sliding windows, and what are the problems. You could look into it, just get the understanding and gist of sliding window and where the windows are being used. Now let's move to the next slide. Now, since we got the intuition of the problem, let's look into the approach how we're going to solve it. Now, for the sliding window techniques, what is the foremost thing required, right? We need two pointers in this case because this is a dynamic sliding window technique. Okay, it is not a fixed size window. The window is variable, but it depends upon the size of the k. Okay, number of zeros we are having in the subsection of the array. So one lookup. This tracks the right boundary of the window. This would be one of our pointer. Zero lookup. This tracks the left boundary of the window, shrinking when needed. Okay, when we are out of k, we try to shrink the subarray, right? In that case, we will be using zero lookup. Now, maxi will be storing the maximum consecutive ones found till now, and flip digit is basically flipping the count of 0 to 1. Okay, and this stores the stores the length of the array nums. Okay, these are the variables which we will be declaring. Now, step 2 is expanding the window with help of one lookup pointer. Okay, this is the right pointer basically. So, moving one lookup forward through the array. Okay, if nums of one lookup is 1, if it is the one present in the array, we will just increment it, right? That's all. We will expand the window. So if this is the window, this is the array, and this is if let assume it to be one for just explanation, sake of explanation, 1 1 1 0 0 1. Okay, if this is one, we will just increase our window, right? Okay. Again, if it is one, we will increase our window, right? As soon as we got zero, right, we check if we can flip it or not, right? Till now we haven't flipped anything, and let's assume flip could be one, right? K is one, so we can flip this. So we flipped it and we included in our subarray. Okay. Else, okay, now this is done. Now, else if we move ahead again here, we cannot flip it anymore, right? So else we exceeds k flips, the window is invalid. So we move zero lookup forward, right? Now, but till now we have to store the length of this array. So what is this? This is 4. And we found out here if it is a 0, we encountered 0 and flips are already been used, right? So what to do? We increment the 0 lookup to or forward by stringing the window, right? Now, let me show you how it is a sliding window technique problem. This is our current window. Till here we took out one length, right? Now we will shrink this. Now we have included this in our array till here, and we will be shrinking it up to here. Okay. As you can see, this will be the window till the infinite side towards the right side, and we have shifted this window from here to here, right? Why shrinking this window is necessary? It is because if we have flipped more than k zeros, we need to restore the validity, right? We have to bring back the k's so that we can use it ahead. And in while loop, we will increment zero lookup until we reduce the number of flipped zeros to k, right? We will be having a while loop in which we will be increment the zero lookup until and unless the k becomes um, or the this flip variable becomes less than k, right? And if nums of lookup is zero, we decrement the flip digit, right? That's it. Now let's move to the next slide. Now we keep on updating our maximum consecutive one subarray by using this formula, subtracting the index of one lookup from the zero lookup index and storing it in the maxi variable. But we always try the longest valid window. Okay. Now we're returning the maximum length at the end. So at every step, whenever this keeps on increasing, we keep on storing the maximum size window we are encountering, right? In the while, okay. And whenever the k reaches or exceeds the flips or the k value, then we put a while loop and we decrement or shrink the array forward towards the left until and unless the flips become less than k. Okay, and if it until now we will and if whenever we encounter a zero, we decrement the flips value. Okay, now how sliding window is helping us in this case, right? And when we encounter zero, what we are doing? We are just flipping it. Okay, encountering the and given the count of flips which we are left with. Now, when we exceed left k flips, we shrink the window from the left instead of recomputing everything from scratch. Because we know that if this window has been utilized already and we have found everything, now the next window from this case will include these values which was already counted in this window till the one where we don't exceeds the k flips, right? And at every step, we track the maximum number of consecutive ones we have been so far instead of recalculating. Like I is here, j is here. Once j came here, we calculate the length. Again, we calculate the length. Again, we calculate the length. Okay. We only modify the count when elements enter or leave the window and prevents redundant work. We only increment the count whenever the count becomes or flips becomes greater than k. Okay. Only we remove it from the value when flips is less than zero, less than k, right? Fine. I hope you understood the approach and the intuition. Now let's move to the next slide. The code is the exact copy of the approach we discussed. Let's understand it line by line. So this is a one lookup and zero lookup. As I explained earlier, this will look for one. It will keep on moving towards right side and it will wait until the k has been exceed. This will store the maximum length and this will store the maximum count of flips we have done till now. And in the while case or the while loop, we're just putting in condition of while one lookup is less than length. Why? Because this is zero lookup here and one lookup here. And one lookup will always be ahead of the zero lookup no matter what. That's why we have just put in condition that whenever one lookup goes out of bound, we will break out through the loop. Now, if one lookup value is 1, we increment the index. Okay. But if one lookup is 0, we will check if the flip digit is less than k. If it is, we increment the flip digit to 1 because we are converting 0 to 1 and we will increment the one lookup. Okay, we will move ahead again. If in this case, again we reach out to a value which is 0 and flips are already been used, what we can do? We will check here while flip dz is equals to k, right? We will increment the 0 lookup. Okay, we will keep on increasing zero lookup until unless we find a 0. As soon as we find a 0, we will decrement the flip digit because we have removed that 0 from our window. Fine, we don't need it anymore. Now new window starts from here or here. Okay, and the next part. Now, if you can see at every case, at every increment of I or every increment of one lookup, we are storing the maximum length we found till now, fine, and return the maxi at the end. So this is all about the code. Now the time complexity is O of n, right? Why O of n? If you can see, we just iterating one time from 0 to n minus 1, fine. And if you have a question that we are iterating I also or 0 lookup also, but it is not like that. If you can see, 0 lookup is just moving ahead. It is not going ahead and starting again, right? It's just moving with the form of sliding window technique. If you can just see, it's just moving this way. That's why the time complexity comes out to be O of n. We are just iterating the complete array once. And space complexity is O of 1 because we are not storing any value in any kind of data structures like list, dictionary, or anything. Okay, now let's move to the next slide. Now, since we have the understanding of the code, let's look at the dry run of the example. Okay, so let me write it here: 1, comma 1, comma 1, comma 0, comma 0, comma 0, comma 1, comma 1, comma 1, comma 1, comma 0. Fine. Now let J be here and let I be here. Okay, and Maxi be something. Let it be empty and let F be the flips. Okay. So if you can see here, J is 1, so J will move ahead and it will store the difference between them, which is 0 comma 1. It will be indexes 0 1 2 3 4 5 6 7 9 and 10, right? So if you can see, 1 minus 0 is 1. J moves ahead. 2 minus 0 is 2, fine. J moves ahead. Now it's 0, if you can flip it, so flip becomes 1. 3 minus 0 is 3. Then J moves ahead. 4, right? We can flip this also because flip is less than K right now. Fine. Flipped it, we became made it 2. So 4 minus 0 is 4 now. J moves ahead. J is again 0. But we store the difference, right? The difference is 5. Now I will move ahead because we have to remove or make flip less than K, right? So I moves ahead. We check the difference between 5 and 1 is 4, less than 5. Okay, difference will be less than 5 here also. Then I comes here. As soon as I comes here, we check that 5 minus 3 gives me 2. It is less than 5, but flip, since I is in 0, we can increment the flip now. Decrement the flip now because we have removed that 0 from our sub array. So our flip becomes 1 again. Okay, and J moves ahead. It's 1. Again, it is 1. Again, it is 1. And every time we are showing the difference. So as it moves ahead, 6 minus 3 gives me 3. 7 minus 3 gives me 4. 8 minus 3 gives me 5. 9 minus, now it comes in 9. 9 minus 3 gives me 6. Fine. As soon as J comes here, it knows that it cannot use the flips again, right? So what happens? I moves ahead. A flip becomes 1 again, right? And J is out of bound. So we get the output as 6. So this is a simple dry run. We just have to move towards right side until unless the flips are not done. And as soon as the flips are done, or it becomes equals to K, we just have to bring I towards the first earliest 0 so that we can decrement the flip and make a new subarray from it. Okay. So I hope you understood the dry run. If you have any doubts or confusion about the solution we arrived at and how we arrived at it, I would suggest going back and understanding the intuition, sliding in the concept and the approach along with the code. After that, do a dry run by yourself on 2-3 examples, and I'm pretty sure you will understand both the solution and the thought process behind it. Now let's move to the next slide. Now, since we are familiar with the problem and the solution, let's move to the lead code and code the solution. So let's declare the variable 1 lookup to 0, then 0 lookup also to 0, then we will store the maximum answer here and with the length of the nums. For that, while 1 lookup is less than n, and also we have to make flip digit also 0. Fine. And if nums of 1 lookup is 1, we increment 1 lookup. Else, if flip digit is less than k, we will increment flip digit because we are in 0th value, right? So we will increment the flip digit. and we'll also increment the one lookup. As flip digit is more than k or equals to k, then while flip digit is equals to k, and if nums of 0 lookup is 0, right? So we have to remove it from our subarray. So we will decrement flip digit, and 0 lookup we will increment the value by 1. Okay, and we will keep on storing the maximum at every iteration. At the end, it will return the max. Let's submit the solution and see. Yeah, our test case got passed. Now let's submit the solution. Okay, we have successfully submitted our solution. Code of the problem is available in my GitHub repository. You can find the link in the description. Thank you, everyone.